Today, we are going to tell you about focusing and removing astigmatism from the primary beam of a scanning electron microscope. Learning these techniques will allow you to obtain the clearest images possible from the SEM. First we will talk about focusing the SEM, after that we will talk about astigmatism. The mechanism of focusing in a scanning electron microscope is magnetic confinement of the electron beam. The column of the SEM has sets of electromagnets, which form electromagnetic lenses, which are used to focus the electron beam in a similar manner to optical microscopy. As the electron leaves the electron gun, its direction is roughly down the column. The magnetic fields collect and collimate the electrons to form a coherent beam. This beam then passes through the condenser lens where it is further collimated. The beam passes through the scanning coils which deflect the beam to allow for the scanning of the specimen. The objective lens is where the majority of the focusing happens, and is the last apparatus through which the beam passes before hitting the sample. By altering the strength and shape of the magnetic field around the objective lens, the focus of the beam can be altered. The image you are now looking at is not in focus. We will demonstrate the process of focusing the SEM. This first step is to use the coarse focus to bring out defined shape. Next, we will use the fine focus knob to bring out the details of these shapes. During this process, you may have noticed that we focused only a small area at once. This is because focusing the beam in a smaller area allows for adjustments to be made more easily to bring out certain features. Now that we have discussed focusing in general, we will talk about focusing at higher magnification. One problem that is encountered at higher magnifications is astigmatism in the beam. Astigmatism is a non-circularity in the beam, which causes distortions in the image that's produced. Astigmatism is caused by many things, including, but not limited to, debris in the column, a non-circular bore in the pole piece of the aperture, and a non-uniformity of magnetic properties of said pole piece. Debris in the column causes distortions in the beam by attracting or repelling the electrons in the beam, acting as an electrostatic lens. This factor is not easily corrected because it is not predictable because more than two charge sources are involved. The non-circularity of the pole piece and the objective lens aperture is caused by imperfections in machining. These imperfections, however slight, cause the magnetic field produced by the aperture to be non-uniform. Another problem with this pole piece that the material it is made from does not have uniform magnetic properties throughout its volume. This adds another factor to the distortion caused by the aperture. Astigmatism is seen as the image being stretched in either direction. Astigmatism is corrected by using the stigmator knobs. These adjust the current through the scanning coils of the SEM, which corrects for the displacement of the electrons caused by the aberrations in the beam. The first step in removing astigmatism from your image is to increase the magnification of your image significantly. Next, focus the image until you cannot improve it anymore. It is now time to use the stigmator knobs to remove stretching of the image in the X and Y directions. Each knob controls the Cartesian axis of the electron beam. As you turn each stigmator knob, you should adjust the fine focus to ensure that the image is, in fact, becoming more focused. Once the image is fully focused and not stretched in either direction, zoom out to your desired magnification. The detailed features of the image should now be in excellent focus and the image of high quality, devoid of stretching in either direction.